In this video, we'll be talking about using AWS Schema Conversion Tool to optimize the existing Amazon Redshift cluster. This special optimization mode was introduced in SCT back in November 2016 when Amazon released a major update for its product. Now we will demonstrate the essentials of Redshift optimization usage for improving the query performance. Just sit back and watch how SCT can easily drop and recreate tables, move data, and eventually improve the performance of your Redshift cluster. Despite the above mentioned, Amazon recommends not to use the same cluster for both source and target of your optimization project. So, before you actually start the optimization project, make sure to create the test Amazon Redshift database to use as the target for the project. The easiest way to fulfill this task is to create a snapshot of an existing cluster. First, log into your Amazon Redshift console. Go to the Snapshot tab, select the cluster you want to optimize, and press the Create Snapshot button. After creating the snapshot manually, you need to select it and execute the Restore from Snapshot command from the Actions drop-down list. Then you have to specify another cluster to restore the snapshot. This newly created cluster can be used as the target in your AWS SCT project. Let's see how long it takes to execute a query in the source database. We have created a special table to demonstrate how optimization works. This table contains 145 million rows, and we intentionally set the bad distribution key for it. Now we will execute the query, which selects top 10,000 rows from this table. Amazon recommends considering results of the second query execution, as the first one may not be precise enough. Next, we launch the query once again and switch to the console to check the execution time for the query. Apparently, the runtime for this query is 83 seconds. Let's get back to our Redshift optimization project. Schema Conversion Tool determines optimization rules based on database statistics. We can collect statistics from the server online or upload it from the file. To start the optimization, we select Collect Statistics action from the pop-up menu. The execution of this operation may require some time. It depends on the user's privileges. For example, using the superuser rights to collect the statistics may take too much time. We can select Upload Statistics from the menu to use statistics from the file. Now we can run the optimization by pressing the Run Optimization button from the pop-up menu. Now you have to specify the migration strategy in the corresponding pop-up window, which appears on the screen. You can choose one of the following options: migration to a copy, migration to a clean slate. The first option lets you consider the data in the target cluster restored from the original cluster. When you select migration to a clean slate, the migration will be completed to an empty environment. Therefore, you will have to take care about migrating the data to the database after applying the converted schemas. The source table initially had the order priority column as the distribution key. After the optimization, Schema Conversion Tool suggests that we use order key, which is actually the right choice. Let's apply the newly created schema to the target warehouse. Traditionally, you have several options of applying the converted schemas to the target database. The first one means direct applying from the SCT application window. The second option gives you an opportunity to save the converted code as SQL. Using this option will help us explore the difference between above-mentioned migration strategies. When we migrate to a copy, the application considers the existing data on the target. You can see it in the following SQL script. We create a new table, insert data from the old table to the new one, rename the old table by adding the old suffix to its name, rename the new table so that it can be used instead of the old one, remove the old table. Now, we can get back to the Redshift and execute the query to check whether the optimization gave us a positive result or not. Once again, we will execute the query twice, and then we will switch to the console to check the runtime for the query. As you can see, the query was executed in just 71 seconds on the optimized Redshift cluster. That's 15% faster than the original result. So, the optimization project was completed successfully. Summing up, you can use your new optimized cluster with increased performance in your applications. Don't forget to use new connection credentials. This completes our overview of Amazon Redshift clusters optimization in the AWS Schema Conversion Tool.